Cycle 2, Lesson 10, Simplifying Rational Expressions. In this lesson, we're going to look at what a rational expression is, and then we're going to look at how we can simplify them. And we're going to also put restrictions on them, because we're going to see that's something that needs to be done in the process of simplifying them. So, remember in grade 9, you learned what a rational number was. It's a number that could be written as a fraction. A rational expression is a polynomial, could be a monomial, one term, or a binomial, or a trinomial, whatever, on top of another one. So we're just taking polynomials and writing them as fractions. So here's a monomial over a monomial. Here's a binomial over a binomial. Here's a trinomial over a trinomial. Those are all different rational expressions. And it doesn't have to be the same type on top as on bottom. I could have a monomial over a binomial. I could have a trinomial over a binomial, whatever. So that's what a rational expression is. Now that we're dealing with things that have variables in the denominator, like x, y, z, x here, that means that there's going to be cases where it's possible to get the denominator equal to 0. That's a problem, because we know that we're not allowed to divide by 0. So restrictions are going to have to be put into place to prevent us from having the denominator of this rational expression equal 0. So for each rational expression, state the restrictions. We're going to start with the restrictions. So here's a binomial over a binomial, x plus 5 over x plus 4. There's no problem with any value of x that we put in there, except if x equals negative 4. Because think what happens if x equals negative 4. If x equals negative 4, then I'm going to end up with negative 4 plus 4 in the denominator. That's going to give me 0, and we know that anything divided by 0 is undefined. That's an error. That's a problem. So instead of writing x equal to negative 4, I'm going to write x cannot equal negative 4. So when I'm writing restrictions, I write an equal sign with a slash through it to show that I'm saying it can't equal negative 4. For B part, again, I want to avoid having the denominator equal 0. Now you might be able to figure out in your head what the number is for this one. Having had some experience, I can tell you that it's going to be 1.4. How am I getting that? Well, I know that 7 over 5 is going to give me 0 in the denominator. But I don't expect you to do that. Here's how you can do it. You can do some rough work, and I'm going to do this way over on the side as rough work. I'm going to try and find out, I'm going to set 5x minus 7, the denominator, equal to 0, and then solve it. And when I do that, whatever x equals is what it actually shouldn't be. It should be my restriction. So solving this, I'll bring the 7 to the other side, and then I'll divide both sides by 5. And so x is 7 over 5, or, as I said, it could be written as 1.4, but we don't have to write as a decimal. But anyway, when x equals 7 over 5, or 1.4, if I were to plug that into the equation, into the expression, 5 times 1.4 equals 7, 7 minus 7 equals 0, we'd have a problem. So again, my restriction is x cannot equal to 7 over 5. I'm going to leave it as a fraction, that's fine. In part C, you can see we've got two different variables. So now we have to consider what's going on with any and all variables. So when will the denominator equal 0 for this one? Well, if a equals 0, then 0 times whatever c is still going to equal 0, isn't it? So we have a problem if a equals 0. But we also have a problem if c equals 0. Because if c equals 0, then 0 squared is still 0, and it doesn't matter what a is. 0 times what anything is 0. So if a or c equals 0, my whole denominator is going to equal 0, and I have an error. So my restriction would be a cannot equal 0, and c cannot equal 0. Again, equal signs with slashes through them to show that it can't equal that. If we've got a quadratic on the denominator, like we have here in factored form, we know that if either of these factors equals 0, the whole denominator is going to equal 0. So just like we found zeros in a quadratic in the past by pulling the numbers out, so from this, the 0 of this would be x equals 3, and the 0 of this would be x equals -4. If I was looking for the zeros of that quadratic, just the one on the bottom, that's what they would be. And really, these are the zeros, but what I want now is to say that they shouldn't equal these numbers, because if x equals +3, let me erase some of this extra stuff. If x equals +3, when I put 3 into this first bracket, 3 minus 3 equals 0, and again, it doesn't matter what the other bracket is, 0 times anything equals 0, so I'd have a problem. Likewise, x cannot equal -4, because if I put -4 into this bracket, -4 plus 4 equals 0, and that's going to be 0 times whatever's in the other bracket, still 0, still an error. Since I've got just the one variable x, I can write it this way. I can write x not equal to, and then I can just list the things it's not equal to if there's more than one. So those are restrictions. I guess I usually will put a comma after, or a semicolon sometimes, but usually I separate them with a comma like that. Rational expressions can be simplified by reducing, just like regular fractions can be simplified by reducing. So anything that I can divide out of the top and the bottom is good, because it'll make it simpler. So when it's in factored form, like this quadratic on the bottom is, that makes things easier, because I can say, okay, x plus 5 can divide into itself, and it can divide into the top as well. So I can divide the top and the bottom by x plus 5. When I divide by x plus 5, when I'm reducing, it just gives me 1, right? When they cancel out, really what I'm doing is dividing by x plus 5. In this case, I got 1. So what I'm left with on the top is 1. And on the bottom, I've got x plus 4 times 1, which is just x plus 4. So they cancel out. And the restrictions, I should have done that first. I will from now on. Usually I like to do the restrictions before I cancel them. The restriction is x cannot equal -4 from this factor, but it also cannot equal -5 from this factor. So there's two restrictions. Even though we cancel out the x plus 5, we still have to put the restriction down for it, because it's considered at any point, if we have the problem with division by 0, then the whole question is going to be an error. So even though at the end it's canceled out, we still had it at some point, so we'll have the restriction there. So that's why I usually like to start with the restrictions. So if we look at B part, again, that one might require a little bit of work. You might want to do it, set 5y minus 2 equal to 0. I'm going to do it in my head because I got some experience with it, but if I set that 5y minus 2 equal to 0 and then solve that, what I'll get is y equals 2 over 5. So if y equals 2/5, then when I put that into the denominator here, 5 times 2/5 would equal 2, and 2 minus 2 would equal 0, I'd have a problem. So y cannot equal 2/5. Again, I need to have that slash through the equal sign. So there's my restriction. And again, I can cancel things as long as they're in factored form. I forgot to mention this. I should have mentioned this in the first case. This is in factored form, right? The x plus 4, the x plus 5, that's factored out. We can only cancel things when they're in factored form. B part is also in factored form. This time it's the numerator that's been factored, but you can see I've got the identical factor in the numerator as I have in the bottom. So on the top, when I reduce, when I simplify, I'd have 5y times 1, which is just 5y over 1, which of course I just write as 5y. So I've got my restriction here, just like I have my restriction here, and I've got my answer here. So I'm looking for both parts when we're simplifying things. In C part, I've got another one which is in factored form, which is very important. And I can look for the factors that are the same on the top as on the bottom. Oops, but I forgot my restrictions again. I want to do those first. So if x equals +2, we've got a problem. So I'll say that x cannot equal +2. Likewise, if x equals negative 2/3, that's going to be a problem, because in the first bracket, if I do 3 times negative 2/3, I'll get negative 2, and then when I add 2 to that, I'll get 0. So those are my two restrictions here. And as for reducing, this x minus 2 will cancel with this x minus 2. And what I'm left with is 1 times x plus 2, or just x plus 2 on the top, and 3x plus 2 times 1 on the bottom, which is just 3x plus 2. So that's my reduced form. So if it's factored, we can cancel out like factors. It has to be 1 on the top with 1 on the bottom. If I had 2 the same on the bottom or 2 the same on the top, those won't cancel. Canceling is always one thing on the top with one thing on the bottom, just like reducing number fractions. So here's a monomial over a monomial. Sometimes people find these ones more confusing than these ones that are in factored form. The best way I can suggest thinking about this is, first of all, notice that there's just one term on the top and one term on the bottom. This is one big term here. This is one big term on the bottom. We got a coefficient, we got an x part, and we got a y part of each term. They're all multiplied together again, though. So I'm going to see what I can reduce amongst the different parts. So just thinking about the 18 and the 15, well, I can think, what goes into both 18 and 15? 3 does. 3 goes into 15 5 times and 18 6 times. What about the x's? I can reduce them. Well, again, just like when I'm looking for a greatest common factor, whatever my lowest exponent is going to give me what I can reduce by. So x squared is what I'm looking for. X squared can go into itself one time, and it can go into x cubed, leaving just x behind. Again, using my power, my exponent laws, I can do x cubed minus x squared, and I do 3 minus 2, this leaves me x to the 1. Likewise for this one, my lowest exponent is the 1 that's assumed to be on the y, so I can divide top and bottom by y, so that cancels out, just leaves the 1, and I can reduce this by 1, giving me 2. Well, I should maybe write it this way, because be consistent, right? This is y to the 2. And what I've got left is 6 times 1 times y to the 2, so it's just 6 times y to the 2 over 5x times 1, which is just 5x. And once again, I forgot to do my restrictions earlier. That's all right. I can still go back and do it now. So when it's a monomial, basically your only restrictions are going to be make sure that the variables don't equal 0, because 0 can be the only problem if it's a monomial. So if x were to equal 0, that would be a problem. If y were to equal 0, that also would be a problem, because that would cause these terms here on the bottom to be 0, which would cause the whole rational function to become 0, or on the denominator, giving me undefined. Now, I stressed up in example 2 that we had to have things in factored form before we could reduce. That's what example 4 is getting at. Often it's necessary to factor before reducing. The only reason it's often necessary is because sometimes they'll be in factored form for us. But if they're not factored, it's always necessary to reduce. If we've got more than one term, a binomial or a trinomial, they absolutely must be factored before we can reduce anything. Really common mistake I see is people, for this one's not factored, right? A common mistake I see is people trying to go, well, 5 goes into 25 5 times, into 35 7 times. Oh, and these x squareds can cancel out. I can't do that. Absolutely can't do that, because it's not in factored form. I don't know how many times I need to say it until I'm satisfied I said it enough times, but do not try to reduce unless you've got something in factored form. So first thing I'm going to do is I'm going to factor. So looking at the top, first thing I always look for is a common factor, don't I? Well, 5 goes into 5x squared, and 5 goes into 25. So I can take 5 out as my GCF of the numerator. I'm left with x squared minus 5 when I do that. As far as the denominator goes, 7 goes into 7 and 35. So I've got, when I take 7 out as my GCF, I'm left with x squared minus 5 as my denominator. Okay, now it's factored. This is factored form. Now I can reduce whatever is the same as on the top and bottom. But before I do that, I want to do my restrictions. Since the only thing that's going to make the denominator equal 0 is if x squared, again, here's some rough work over here. If x squared minus 5 equals 0, then 0 times 7 is going to make the whole denominator equal 0, right? So what's going to make x squared minus 5 equal 0? Well, again, I can do it as a separate equation. I could do x squared equals 5 if I rearrange a bit. If x equals plus or minus the square root of 5. Remember, we've talked about this before as well. If I take the square root of something while solving an equation, I have to consider plus and minus. So if x was the positive square root of 5 or the negative square root of 5, either one of those is a problem. Because when I stuck that back in here, positive square root of 5 squared is just 5. And 5 minus 5 is 0, and 0 times 7 is 0. Same thing happens though if I put the negative square root of 5 in there. Negative square root of 5 times negative square root of 5 would give me positive 5. Minus 5 would be 0. Times 7 would still be 0. So there's two restrictions here. It's x cannot equal the square root of 5 or the negative square root of 5. I could write it the same as just plus or minus like I did here, but I want to be extra specific in this case just to make sure I'm being clear. So there's two restrictions, plus or minus the square root of 5. Now back to reducing. Now that it is factored, I can reduce any factor with any other factor. And the x squared minus 5 does cancel out on the top and the bottom. So what I'm left with is 5 over 7. But I still have to have that restriction. Even though the variables went away altogether, I still have to have that restriction. B part, I've got a binomial over a trinomial, and it's not in factored form. I absolutely have to factor this before I start trying to cross stuff off. Again, I get people doing this kind of nonsense, trying to cross off the x squareds, but it doesn't make any sense. Must be factored. So on the top, I got a difference of squares. So it would be x plus 3 and x minus 3. On the bottom, I've got a complex trinomial. When I look at the bottom, I don't see any common factor, so I might need to do a bit of rough work on my factoring just to find out what the denominator is going to be. So again, for the first term, the 2x squared, I'd have 2x and 1x. For the 15, I'll take a couple numbers that are close together, like 3 and 5. Just a little experience tells me that if I put the 5 first and then the 3, I think that's going to work best. So 2x times 3 gives me 6x, 1x times 5 gives me 5x. If I subtract them, I'll be able to get the 1x. It's the middle term here. And I want it to be a positive x. That means I need to make this a positive 6x and a minus 5x to give me that positive 1x. So where did the 5x come from? It came from the 1x times 5. So I'll put the minus sign in front of the 5, plus sign in front of the 3. Here's my two factors. 2x minus 5 and x plus 3. Okay, now it's in factored form. At this point, I'll get my restrictions. So from this factor, x cannot equal negative 3. And from this factor, x cannot equal positive 5 over 2, or 2.5. And again, I'm just doing it in my head, but you could always do some rough work where you just set 2x minus 5 equal to 0 and solve it. You'll get 2.5 or 5 over 2 when you do that. There's my restriction. There. And as for simplifying, again, now that it's factored, and only now that it's factored, I can reduce the x plus 3's that are on the top and bottom. And what I get is 1 times x minus 3 just gives me x minus 3. 2x minus 5 times 1 gives me 2x minus 5. And there's the solution. What do we have? Oh, lots more examples. Goodness gracious. All right. Remember when factoring to check for different types of factoring in this order. Common factor first, everything else second. So just emphasizing the importance of always common factoring. So since we got lots of examples, let's not linger over any one of them. So I have to factor this one. Common factor, 3 goes into 3 and 12, gives me 3 times x minus 4. 7 goes into 7 and 28, gives me 7 type bracket x minus 4. I can see my restriction, x can't equal 4, can it? And as for reducing, now that it's factored, the x minus 4's cancel out. I'm left with 3 over 7. For this one, again, look for a common factor. I can definitely take a 2 out, but I can also take an x out in the numerator. When I do that, I'm left with x plus 3. On the bottom, I can take a 5 and an x out as my GCF, and when I do that, I'm left with x plus 3. Funny how these always work out to have something that can be canceled out after I do it. Be really careful about these restrictions. I'm going to guess that, just take a look at it. I'm going to guess everyone sees that I should have a restriction that x can't equal negative 3. But does everyone see the other restriction that needs to be there? If you said that x can't equal 0, then you would be correct. Because if this x here equals 0, then what's going to happen is the whole denominator is going to equal 0, and we'll have a division by 0. So this, when you have a monomial like this as one of your factors on the denominator, it's always going to give you a restriction of x can't equal 0 in that case. So watch out for that. Anyway, there's my restrictions. X plus 3 cancels out in each case. And in fact, I can also cancel out the x and the x here, right? 2x over 5x. All I'm left with is the 2/5. Again, it reduces down quite a bit. There's no variable left at all, but I still have to have that restriction there. C part, again, factor. Okay, it's a simple trinomial. There's no common factor on the top. Two things that multiply to give negative 10 and add to give negative 3. I know it's 5 and 2. If I make the 5 negative and the 2 positive, that would work out. On the bottom, it's a difference of squares. So it's x plus 5 and x minus 5. It doesn't matter which order. You could do minus 5 first. It's absolutely the same thing. My restrictions, x cannot equal minus 5 or positive 5. I'm going to write them separately again, but you could do plus or minus 5. The x minus 5 is my common factor that's on the top and the bottom, so I'll cancel those out. And I'm left with x plus 2 over x plus 5 as my simplified version, with the restrictions where x cannot equal plus or minus 5. D part is another one of those tricky monomial ones. So we can't common factor a monomial. All we can do is reduce the individual parts. First, I'll do the restrictions, though. Again, remember what I said before. If it's a monomial, just whatever your variables are on the bottom can't equal 0. So x can't equal 0 and y can't equal 0. If that ever happens for either one of these, I'm going to get division by 0. And as for reducing, this is the part where I just took the coefficients. What's the biggest number that goes into negative 49 and 21? Well, it's 7. 7 goes into 21 3 times, and negative 49 times, negative 7 times. It's probably good to write it down as I go along. So I'd have negative 7 over 3. As far as the x squareds go, these cancel out, don't they? As far as the y cubed and the y goes, again, my lowest is y. Y goes into itself, and it goes into y cubed, leaving y squared. So I have y squared on the top. And so that's as far as I can go for this monomial. Sometimes, in order to simplify a rational expression, we need to remove a common factor of negative 1 so that the signs work out. Also, it's always acceptable to rearrange the order of the terms if necessary. So, simplifying state restrictions. X minus y over y minus x. Sometimes people think these are the same and they just go, okay, I can reduce that. They're close to being the same, but they're not identical. The signs are different on these guys. Here's what you should do. Always rewrite things in alphabetical order. I've said this before when writing terms. If you got more than one variable, write them in alphabetical order. So the numerator is already good. X comes first, then y. Let's rewrite the denominator with the x first. Of course, the minus sign goes with the x. So when I rearrange it, I'm going to get minus x plus y. As soon as I do that, I can see that the top and the bottom aren't the same thing, are they? The restriction is also kind of funny in this case because it's not that x can't equal 0 or that y can't equal 0. Because we got these two variables added together, they really relate to each other. Think about when is the denominator going to equal 0? What if x equaled 5? If x equaled 5, then the denominator is going to equal 0 if y also equals 5. Right? Negative 5 plus 5 would be 0. But I just picked that number. What if x equaled 10? Well, then I'd have negative x, negative 10. And if y also equals 10, then again I'm going to get the denominator equals 0. So it's not an absolute restriction. What it is, in this case, if x is equal to y, then they're going to cancel each other out. So my restriction has to be that x can't equal y. So whatever x is, as long as y isn't the same number, then I'm not going to get division by 0. So that's a little bit of a different restriction, but I hope that makes sense. As for the actual reducing, we still have to think about it like it's factored, right? We can't reduce things unless they're identical. So that's what this part about removing a common factor of negative 1 does. So sometimes, like in this case, if I were to common factor the denominator, so I'm writing the top the exact same, if I were to common factor the denominator and take out a negative 1, then taking that minus sign out of the bottom, what I'd be left with is x, and then I'd have minus y on the bottom. And now I have the exact same thing on the top as I do on the bottom. The x minus y, and it would cancel the x minus y on the bottom, the one on the top with the one on the bottom. I still have that minus sign there though, don't I? So I'd end up with 1 over negative 1, which of course just reduces to negative 1. So they don't cancel exactly. In this case, they have opposite signs. So let's be careful with that. B part, again, let's put them in alphabetical order. The numerator's fine to start with. The denominator should be rewritten as negative 3x plus y, just like in the last example. Let's factor the top and bottom. The top's a difference of squares. So I'm going to have 3x plus y and 3x minus y. The bottom, I'm going to do what I did in the last one. I'm going to take out negative 1 as my denominator, or just negative sign. That gives me 3x minus y on the bottom. This is a good time to do the restriction. Again, it's going to be a relative restriction. If y is 3 times bigger than x, I'm going to have a problem. In other words, again, here's some rough work over here. When 3x minus y equals 0, we're going to have division by 0. Well, that's going to occur if, let's see, 3x equals y. If x equals y over 3, that's going to be a problem. So that would be my restriction here. X cannot equal y over 3. So if x was 9, then y could not equal 3. I have that backwards? No, if x is 3, then y could not equal 9. So there's my restriction. And again, now that it's factored, and only now that it's factored, I can cross out one factor from the top and one factor from the bottom. That leaves me with 3x plus y times 1, or just 3x plus y on the top, and negative 1 on the bottom. Again, I wouldn't leave it like that. 3x plus y divided by -1 is just going to change all the signs. I could write it as -3x minus y when I divide both terms by -1. And that is the end of the lesson. So some complicated stuff here. I'm not going to lie. This is some stuff that some people are going to run into problems with, because restrictions, you have to be, be very careful with them. If you can't factor well, then that's going to trip you up. So you got to keep practicing your factoring, and you got to be really careful about only canceling things once you factored. If you try to do it without factoring, then that's a big heads up that you've missed something. Oh, I see I've missed one more example. Lucky me. Lucky us, we got one more. All right, I'll try not to take too long on it. Let's see, the top. Let's just rewrite it first of all, actually. So I got x squared. I'll rewrite the top exactly the same. On the bottom, I've got -x plus 2. Now I'll factor. On the top, I'm going to have x minus 2. On the bottom, x minus 2 times x plus 1. That would multiply to give -2. Add to give -1. On the bottom, if I take out that -1 again, I'll have x minus 2 on the bottom. My restriction is pretty straightforward in this case. If x equals 2, I'm going to have a problem, so x cannot equal 2 is my restriction. If I reduce, the x minus 2's cancel out now that it's in factored form. What I'm left with is 1 times x plus 1 on the top, so just x plus 1, and -1 on the bottom. And as we already saw, if I divide x plus 1 by -1, each term, the sign changes and it becomes x minus 1. Now we're done. Good luck with the homework.